Part 2, surface conditions of climate. This is what they conceptualize the surface of it being. Yep, there's this star. Proxima is located with the classical habitable of a star and receives about 65% of Earth's radiation. Its temperature is to be about 234 K, minus 38 Fahrenheit. Various factors such as the orbital properties of Proxima b, the maximum radiation emitted by Proxima Centauri, and the behavior of clouds and hazes influence the climate of an atmosphere bearing Proxima Centauri b. There are two likely scenarios for the atmosphere of Proxima Centauri b. In one case, the planet's water could have condensed and the hydrogen would have been lost to space, which would have only left oxygen or carbon dioxide in the atmosphere. After the planet's early history, however, it is also possible that Proxima Centauri b had a primordial hydrogen atmosphere or formed further away from its star, which would have reduced the escape of water. So Proxima Centauri b may have kept its water beyond its early history. If an atmosphere exists, it is likely to carry oxygen-bearing gases such as oxygen and carbon dioxide. Together with the star's magnetic activity, they would give rise to a rose that would could be observed from Earth if the planet had a magnetic field. Climate models, including general circulation models used for Earth's climate, have been used to simulate the property of Proxima Centauri b's atmosphere, depending on its properties such as whether it is tidally locked, the amount of water, and the carbon dioxide. A number of scenarios are possible. A planet partially or wholly covered with ice, a planet wide or small oceans, or only dry land. Combination between these snails with one or two eyeballs or lobster-shaped areas with liquid water, meaning near the equator with two nearly identical areas on each hemisphere, resulting from the equator like lobster claws. A subsurface ocean with a thin, less than a kilometer ice cover that may be slushy in some places. Additional factors are nature of convection, the dispersion of continents, which can strain a carbonate circuit cycling through stabilize the atmospheric carbon dioxide concentration, the effects of galactic comet rays, which are expected to be more significant around B than around Earth, ocean heat transport, which broadens the space for habitable climates, ocean salinity variations that alter the posture of an ocean, ozone chemistry, which can increase the stratospheric temperature and influence surface temperatures, rotational period of the planet, which determine the Rossby wave dynamics, internal heat flow, which can melt the bases of ice sheets, sea ice dynamics, which could cause global oceans to freeze over. Man, stability of an atmosphere. The stability of an atmosphere is a major issue for the habitability of Proxima Centauri b as a result of several current unknown factors. Strong irradiation by UV radiation X-rays from Proxima Centauri constitutes a challenge to habitability. Proxima Centauri b receives about 10 to 60% as much of this radiation, especially X-rays as Earth. It might have received even more in the past, adding up to 7 to 16 times as much radiation than Earth. Solar winds and coronal mass ejections are even a bigger threat to an atmosphere. I mean, it's out of this world, the threats to this planet. The amount of solar winds impacting Proxima Centauri b may be 4 to 80 times that impacting Earth, with a pressure 10,000 times larger than the sun's solar winds. Damn. Amazing. These stars are really bad for planets. I mean, Proxima Centauri be distant for the star. The star winds are likely to be distant around Earth by a factor of 10 to 1,000 times, depending on the strength and stage of Proxima Centauri's magnetic field. And I'm just going to generalize this. If planets are locked to the star, the planet can collapse on the night side. That's where it can collapse on the night side. This is particularly a risk for carbon dioxide dominated. I mean, if it's thick enough, you can have it, strong enough a convective cell. I don't think that would happen, but if it's really thin, yeah, maybe. Unlike the sun-like star, Proxima Centauri would have been further away early in the star's existence when the star was in its pre-main sequence stage. So that's interesting. Could have ran into suffered a runaway greenhouse effect, which the planet water would have evaporated. Damn. Interesting. Ash covered planet with a subsurface Earth is expected to have cryogenic activity at rates equal to volcanoes on Jupiter's moon. Oh, damn. Even if proximity to be lost its original threat, okay, actually could be built after some time. A second asteroid would likely contain carbon dioxide, which would make it more stable than Earth's atmosphere. Particularly in the presence of an ocean, which, depending on its size as well as the atmospheric mass and composition, may contribute to preventing atmospheric collapse. Additionally, impacts of exocomets could resupply water to Proxima Centauri B if they are present. I mean, I think it most likely you have this eyeball because it's likely tightly locked, and you have this convective cell. If there's oceans on the light side, then it's likely colored up. I mean, and on the edges you have this habitable zone. Then you have probably you know, you have sick on the backside. But yeah, that's an educated guess, I guess. Possibility of life, the context of extra research have used to find out the possibility that liquid water exists on the surface of the planet. As normally understood in the context of extraplanet life, liquid water on the surface and atmosphere are prerequisites for habitability. Any life limited to the subsurface of a planet, such as a subsurface ocean like those of that reside in Europa and the source would be difficult to detect from afar. Setbacks to habitability. They have a red dwarf a controversial subject. Eh, so it would be tighter locked because it's too close to the planet. UV radiation, which we talked about earlier, would produce less of an ozone. Star activity could deplete ozone layers sufficiently to increase UV radiation dangerous levels. Depending on this, it may partially lie outside the habitable zone. Oxygen or carbon dioxide may build up in the atmosphere of proximity to toxic levels. If oceans are present, the tides could lead to the flooding and drying out coastal landscape, triggering chemical reaction conducive to the life favor the biological rhythms such as the day-night cycle, which would otherwise not develop in a entirely locked planet without a day-night cycle. Yeah. On the other hand, red dwarfs actually have a lifespan much longer than the Earth. I mean, much longer than our sun. Yeah. One study in 2017 estimated that the productivity of a Proxima Centauri B ecosystem based on processes may be about 20% of Earth. Uh, Observations and exploration. As of 2021, Proxima Centauri B has not yet been directly imaged as its separation from Proxima Centauri is too small. It is unlikely to transit Proxima Centauri. Um, yeah. Further larger ground telescopes in space observations such as the James Webb and Jesse Grace Owen Space Telescope could directly observe this planet, but distinguishing the planet from its star would be difficult. Uh-huh. Interesting. They might try to send the Breakthrough Starship project, which aims to develop electric power systems that can reach Proxima Centauri. I doubt in the 21st century. Views from Proxima Centauri view from the surface of Proxima Centauri view B, the binary star Alpha Centauri would be considerably larger than Venus is from Earth, with a apparent magnitude of minus 6.8 and minus 5.2 respectively. The Sun would appear as a white star with a apparent magnitude of zero point 0.4 in the constellation of Cassiopeia. Yeah, interesting. And here's the models of this planet. Let's take a look at it. I mean, this this is what it probably would look like. You have this eyeball, and you have this cell which would distribute the warmth along the other side of the planet. You have convection increasing and decreasing on the other side of the planet. And let's take a look at this one. This is another one. I mean, this would probably be a less efficient one. Which the other one would be very efficient. This one would be very much less efficient. With the eyeball, the eyeball here on the daylight side, and the night side not much cooler. Maybe 60 to 75 below on one side. Well, it's. I mean, I mean, depending. This could be 200 degrees Fahrenheit in here, or 100 C. I mean, depending on what kind of atmosphere you're dealing with. So this is what we have on this planet.